Hi, my name is Cece Hall, and I'm an applications analyst here at LI-COR Biosciences. In this video, we will cover stability criteria, what they are and how you would set them up. So first of all, what are stability criteria? Stability criteria are a way for you to tell the instrument or yourself when things are stable and it's time to log a data point. So you can use those, for example, in a response program if you want the instrument to automatically log a data point when things are stable. Or you can use them to remove subjectivity during, example, a survey measurement. So you set them up beforehand and then the user would log them manually whenever things are stable. Another thing is what parameters do you want to use or what variables do you want to track for your stability criteria. That sort of depends on what variables you're interested in measuring. So for example, a simulation, you probably want to use something that goes into a simulation. It could be a simulation itself or delta CO2. For stomatoconductance conductance, it could be stomatoconductance conductance, transpiration, or delta H2O. And next here, I will do a little experiment to just determine the stability criteria on a plant. So to determine my stability criteria, I've picked a greenhouse grown corn plant that I've clamped on and increased. It was originally dark adapted, but I've increased the light intensity to about 500 micromoles of light. And it's sitting in this chamber acclimating to this new light set point. So I'm going to use this plant to determine my criteria. So what we'll do to set up the criteria is that we'll go to this log setup screen over here. And under stability, we already have 3 defaults. These may be good for your plants. These might be the ones you want to look at, but just for practice here, we're going to delete all these and I'll show you how to add them. So for my plant, I'm interested in simulation, conductance, and I do have a fluorometer attached, so I'm going to be interested in fluorescence as well. So we'll do new here. In this drop-down menu, we'll have to go to the one, I know that both my conductance and my simulation will be in the gas exchange group. Sorry, I'm scrolling over. So here, the simulation rate, apply. For this one, for all of mine, I want to control on slope limit. You could control on standard deviation, that's up to you. But I'll do slope limit, so we'll select here slope limit, a period. For a period, pick something between, I would say, 15 to 30 seconds. I'm going to go with something in between there, so 20 seconds. That's how long it uses this, calculates the slope over. And then we'll add conductance, and that's also in the gas exchange group. Right here, apply. We'll also control on slope. Change this time to 20 seconds as well. I'll add one more. And that's going to be fluorescence, and that's going to be in the FLUR group, I believe. Actually, it's going to be in the FLUR LS group. F here, demodulated fluorescence. As you can see, these already have a default in them, so we have one for each. That might be good for your plant, may not. So we want to do a little test to figure out if these are right or not. And first of all, I need to change this one to 20 seconds as well. So what we'll do is that we'll go to the measurements tab, and I'm going to start here at graph A. And I'm going to set it up so that I'm plotting my variable that I'm interested in, so A on the left axis, and then I'm going to plot the slope on the right axis. So to do that, we'll go in here to edit graph. On my left axis here, I have A, and then conductance. We're going to change this conductance value to the slope for A, which is going to be in the stability group right here. Stability. Here we have different parameter things, but here we have A slope. Apply. To make things a little easier to visualize, we're going to change this green color for slope to red. So we'll click here, select the color. Okay, now we can see it more clearly. Right now it is auto scaling. We might want to keep this, but for this purpose of this, we'll change this auto scale to a value. And we're going to set this to 5. Is that what it is? Oops. 5. Yeah, we'll leave it here at 5. Just a little bit easier to see that slope. And I've already done the same thing here for B and F. So on B, we have our conductance, and then on F here, we have our fluorescence. So now all we need to do is just sit here and wait until we think things look stable. So here, you may be very zoomed in. We see here on the y-axis on the left side, it's pretty small scale. So you might want to just zoom out a little bit to get a better idea of if things are getting stable. And we can see here that it's starting to look pretty stable. So maybe here in a little bit, I determined that, okay, for this plant, you know, this is stable. Now what is my slope? Let me go look at conductance as well. So conductance is still sort of, let's see, let's zoom out here. Still kind of creeping up a little bit. And then what about our fluorescence? Okay, here it's also very zoomed in, so we'll zoom out a bit. Looks like it's still creeping up some. Still have to wait to be patient. So if I do think this looks stable, I can go back here to my log setup and my stability criteria, and I can see what the current value is. So right now for my slope, it's jumping between, it's about 0.45, 0.5. So I might use something just a little bit larger than that, 0.6 or something for my slope. And I do think, I would say this is stable. It's starting to settle in here around 17.5 for this plant. So I'm going to go ahead and decide that it's stable. I think it's stable. So we'll go in here and look, okay, 0.5, 0.6. We'll do a slope limit of 0.6 right here. Okay, so my A is complete, so I've decided that one. My B is still sort of reaching a steady state. And then my F is still sort of increasing as well, starting to kind of plateau. And this again is where you have to decide, maybe this is stable, maybe you think this is stable. You know, it hasn't changed by very much here in the last couple of minutes. So we set the slope limit for assimilation already, and now looking at this conductance, there is some bouncing around here, but if we zoom out and if we look at the Y scale here, it's very, very tiny differences. So I'm going to say it's stable, and looking at this one, I need to pick a slope that's something like less than 0.02. Somewhere we can look at this stability here to get an idea what the slope is right now. It's very tiny. So back again here, I'm going to say within 0.01 I capture stability. So we'll go in here, go to our model conductance and do 0.01. Done. Okay, so we've set 2 out of 3. And then for fluorescence, this may be stable for you, but I'm going to set it up the same way as I did the other. So just looking at kind of what the slope is when things look stable, and then use that slope for my criteria. And that's a way to set up your stability criteria. As always, we have more resources on our website. You can always contact LI-COR for support, or you can contact your local distributor.